Hello, this is Unexpected, Unreasonable, Unfixable, Filesystem Attacks on macOS. You might not see it in the back rows, but this presentation is certifiably stupid. It actually says rated RS for really stupid. My name is Gergely. I'm from Hungary, but it's very hard to pronounce. In case you can't make it out, it's a 4 out of 5 on the pronunciation scale, so you can call me Greg. It works all the same. I'm a lifetime nerd. I did a lot of Linux, hacking, networking, coding in C, and stuff like that, so I'm very, very new to macOS. I had a bunch of weird jobs, but right now I work as an independent bug hunter in the Apple Security Bounty Program, and my views are mine and mine alone. Today we're going to take a look at attacking file operations on macOS, and this is the condensed version, which is probably a good thing. More info can be found on my blog, which is also in the... I don't think you can make that out. Ah, well. This will all be available. These are, what I'm talking about, are going to be, well, there were 0 days at some point, there no longer are. And more blog posts will be followed up by this. So why would we attack file operations? Well, because they're very simple, they're easy to find, they're easy to exploit, and I'm very familiar with them. They are very ubiquitous, they're everywhere, and we take it for granted. So actually we can do all sorts of nasty, nasty things that I didn't know existed on macOS. And most of these are going to be race conditions. They're very good because a failed exploit has no downside. So I can try again and again and again, and it's all going to work fine. They're very dangerous. We know this because there's a classic trove of user-to-root LPEs that we have all seen. However, Apple introduced the rootless feature with TCC and entitlements and all of this. And for all intents and purposes, this rug pulls POSIX and 30 years of expectations and millions of lines of open source code that doesn't expect this. So also nobody's paying attention for some reason for this. I was looking for talks like this, and none seem to exist, or I just really suck at Google, which is also the case. But that's good, because learning all this PPL pack stuff is just seems really hard. I mean, this terminology I just introduced, I'm going to use LP as a classic user-to-root LP, and the TCC bypass going from user to user who has full disk access. That's good because you can access camera, location, contacts, and whatnot. So how hard are file operations? Well, they're a little hard. And this is just POSIX. So this is what you can do with POSIX only. Now this is all Linux, Unix, traditional stuff, all that good thing. That is Apple. They put this on top, and the problem is that the interactions between all of these are exponential. So, yeah, good luck. I'm not going to go into all of this, but I have my bag of dirty tricks. So basically, there are a bunch of racy stuff, like talk-tos, renames. I can reshape the file system graph while it's being used. I can set the CVD to a non-existent directory, hardlink a directory, hardlink a symlink, something that sounds ludicrous, and that's because it is. You can use inheriting ACLs, which you didn't know about. They exist. By the way, the specification for that is revoked, so take this as you might. Apple also relies extensively on extended attributes to provide system security, including the quarantine attributes. An extension of that is Apple single, Apple double files. In case a file system does not support it, you can mess with that without impunity. With impunity? I'm not quite sure. You can rug pull all the programs. This is especially dangerous. You can do that by force unmounting or moving the mount point. And I'm not done. You can mount as a user. This is basically the thing that kicked all of this off, is that this seemed like a very ludicrous thing to do. And you can mount, you can pick your file system. You can have a network file system, a legacy one. You can pick options. You can change the options at runtime. You can update it in place. You can even change the file system encoding in some places. You can just use file systems that do not support extended attributes at all. And you can corrupt the file system image, which is just glorious, and is the holy grail, really the idea why you shouldn't be doing this in the first place. Because there's nothing preventing me from taking a volume and then just messing with it. It's very easy. And while I might not be able to do anything useful in kernel land because the kernel would crash or the file system driver would, go tits up, that would be fine, not so fine. However, you could just change all the hard links. You can make you can make impossible structures possible. Think about the directory hard link, or think about symlinking hard linking the dot directory, not to its parent, but to its parent's parent. You go 3 down, you go 3 up, you end up 4 up. What the hell happened? You can do that. Because speed will always trump security. always. Because the file system driver will not be able to verify everything. What if it's a petabyte? Like, they're not going to check every single inode. That would be ludicrous. So, they are hard. This is very, very difficult stuff. And an unprivileged user can do all or any of this in any combination they desire. So basically, not the end of the world, right? We have seen this. And however, Apple's in a very tough spot. I don't know why they did it this way. Android does it in a completely different way. Every single process is their own separate UID. And probably Apple had very, very good reasons. Reasons that I do know. And if you do, my DMs are always open. And yes, without having complete file system isolation between UIDs or processes that you actually want to have a security boundary between, this will never be secure. But in all fairness, TCC is much better than not having anything. So, my focus, there's a bunch of stuff you can do, there's really a lot of stuff, but my two favorites are open and rename, because they're everywhere, and they're surprisingly hard to mess up, and we think, oh, they're very simple operations, but if you have ever looked at kernel source code, you see that that is definitely not the case. And they're very useful for me, because they're good for the traditional LPEs and for TCC bypasses. The other promising ones are really good, but they're either tricky to exploit, or rare, or only good for LPEs, and I really wanted to find something big, you know, like why would just, you know, chmod's pretty rare. So I need to do two things to be successful here. One is file path control, and the other one is file content control. Obviously, the more control I have in either of these two domains, the higher severity the vulnerability is. Now, I do have, well, primitive, I guess, for partial content and partial path control. You just mess with sudo. Sudo is lovely. You can just dump a file with a random name with mostly garbage content. As long as you have one valid line, you can dump this under etc sudo.d, and it's going to gobble it up, and everything's going to be fantastic. Now, with TCC, you can't really do this. Like, you have to control stuff exactly at the exact location, and that makes my job very hard. However, if you know about something like that, DMs are open. So we have a couple allies as well. As I said, sudo is absolutely lovely. There's a large amount of massive untitled apps, like music and stuff that doesn't really, shouldn't be having an FDA, but does. There are bad POSIX APIs. Oh, no follow is, everybody knows that's bad, right? Who thinks oh, no follow is good? Hands up. Yeah, well, security crowd, go figure. Well, most programmers probably don't, because they think, oh, no follow, yeah, that's what I need. Well, not really. It will only not follow the symlink if it's the last path component. There's an atomic rename, actually, in this is not in POSIX, that we can use to very, very quickly swap to inodes. And that's very good, because I'm racing stuff, so the quicker the better. And user mounting, as I previously said. There are also string truncation bugs, which are normally irrelevant, maybe informative, who cares? Well, guess what? This can turn a partial path control into a full path control, which is deadly in this situation. This is very common, actually. Also, there are rename bugs. So rename, by design, always follows symlinks. There's no way to prevent it. So POSIX doesn't really give you any API that doesn't follow symlinks, so good luck. And renaming A to B in the same directory is actually a race condition, because they're looked up separately, and the current working directory is implicit. So if I control any path in that, I can essentially end up with something like this, is where I have a source directory with a file name in it, where I have full content control, and I can shoot it over, beam it over to something else /b. Problem is, I do not fully control the file name. File name control is very important, but this is already, pretty bad. So, with all that, I am looking for, well, basically these, you can figure this out very quickly. It's bad paths and bad missing flags. The classic access open races, which are proven to be impossible to solve. A file copy and a file recreation. POSIX doesn't give you an API for that. There are some Mac APIs, but as I said, POSIX doesn't give you it. So basically you read a file and you open a new one and then write it out. Everybody has to do that boilerplate, and that is everywhere. File recreation also. If a program wants to be helpful, you delete the config file and see if it shows up again. If it does, well, probably somebody put it there, and they did remember the contents. So, that's not really good. There are sticky renames, again, bad paths, dangerous renames, yeah, nobody cares. So here are the bugs. There were originally 7 of them, but I don't have a lot of time, and you guys are probably bored already. So I'm just going to show you 5. The other 2 are already on my blog. I'm just going to very quickly go through that. So Librarian was a TCC bypass. It was a fully controlled rename in music. Basically, you copied a file to music's input directory, and they moved it to your library. That was done insecurely with me being able to fully control the entire path and what got moved. So I overwrote TCCDB, GG, easy bounty. And there was an unnamed sandbox escape. It's unnamed because I forgot to name it, because if you haven't figured it out by now, I have ADHD. So the sandbox escape was by basically preventing the quarantine attributes from being placed, because I just could mount the DevFS volume, and then I could create files and symlinks on it, which is just enough to create my fake app and escape the sandbox. Right, so let's start with the first one, letter Alice. This is a TCC bypass. It's a funny one. MTL has this environment variable that is very ominous. If you set this, it will write a log file to an attacker-provided location. It does this with ns file manager, create filelet path. It really actually opens a temp file, The access are random, but you don't really care because it's case insensitive anyway. But the basic idea is that it opens a new file, writes the contents, and calls the rename. And this is the most important part. I control all of this. Sorry, I control all of that. So it's a dangerous rename with full control over the path. However, how do I control the content? I don't know what's in that log file, and to be honest, I don't really care. If I try to overwrite TCCDB directly, I won't be able to really control the content as I would wish. However, if I point it to any other location that I control, I can catch the temp file, open a file descriptor, or replace the file, or do whatever, and then I just raise the rename. If I replace the directory with a symlink between the src and the st lookups, I can exactly overwrite TCCDB with the atomic swap, full control over path and contents. Here's a demo of that. I only do videos because the thing we're aiming here is getting automation access over Finder, because Finder always has this. As you can see, I have gained automation access and probably left a couple lines of logs behind, but that's it. That's the whole thing. Next one, SQLOL. This is very fun. This is an SQLite, only on macOS. This was a libsqlite compiled with SQLite-enabled SQLog. This was a debug functionality in production. And basically, you could make SQLite write the SQLite DB, a query log, and an index file into a directory that an attacker provides. The files are created with open, but since this code was never meant to run in production, they never really bothered to secure it, so it follows symlinks and overwrites files. It was a trivial info leak, but I wanted more. And controlling the file name is obviously trivial. The file name is not really random, it's a tiny, tiny bit random, so it's fine, we can symlink it. Controlling the content is a bit tricky. I can overwrite files, but only with the SQLite DB or the statement log or the index, but I needed to exactly control every single bit of it, yeah? So, yeah, this stumped me quite a bit, but I had to realize something. The TCC DB is an SQLite DB, and an SQLite DB has more than one table. And applications generally don't really care if you have more than one table in your SQLite database. So if I have a target like music, I really love music, most of this is exploiting music, I can basically create music, has this fancy DB called cache.db, and I can basically take valid TCC tables and put it into cache. And when music just recreates it, or as libsqlite recreates it, I will have a completely valid TCC DB with a couple additional tables in it, but nobody really cares, and TCCD eats it up, so it's, yeah, that's it. We don't even need to race, like we just symlink it and it's done. That's how that looks. Again, we're doing the automation thing. Yay. Thank you. So, number 3, spat signal. This is a collision, one of my first bugs in the Apple thing. It was a collision with Joshua Mason. Very nice guy. I messaged him on LinkedIn. He wrote me back in half an hour. Super cool. I created a couple bypasses for it. I didn't get the credits. I only got a small bounty, not a very small one, but it was a weird experience. So basically the bug is that Spotlight performs file operations on user-mounted volumes. Now, knowing all of this and where this presentation is headed, you probably know that this is not a great idea. Spotlight's daemons, MDS and MDS stores, are running as root, and MDS even has FDA, but we don't really care about that. And the way this is secured is that there's a top-level directory on the volume called Spotlight v100. And we're not allowed to write to it because SIP doesn't let us. However, you cannot really protect the files if the files are not there. Like, okay, this guy's crazy, right? Well, you can unmount the disk, and you can hex edit the HFS volume, and change that. Change 1 byte, any byte, really, doesn't matter. The regex is not going to match, and HFS is fine because there's no checksums. SIP, Spotlight won't care, and SIP won't notice. So how do you, yeah, so exactly, I think the bug is the fact that this is even happening. It opens the doors to anything and everything. So one of the bugs is that Spotlight has these cache files that it writes out, that if I copy a PDF over, it has an inode, and Spotlight is helpful and going to create an x.txt, where the x is the original file name's inode, with the content indexed as a txt in it. So I know the file's name, and I control the content exactly. Well, this is pretty brilliant, because I can just symlink that directory, do all the regex, hex editing back, mount it up, trigger a Spotlight reindex, and sudoers is going to get overwritten. The fix for that is Spotlight no longer likes symlinks. Bummer. However, I don't want to meme on Apple too much, but it's a regular accession engine, Point is, it's not file system aware. It doesn't really understand mount points. Mount points are transparent, hard links are transparent, symlinks are transparent, and it's all good, really, because otherwise it would be very difficult to write anything. But it's still matching regular expressions. So hard links are sort of like symlinks, only if they're on the same volume. And can we merge them? Well, you saw the amount of shenanigans was going on. Like, probably, the answer is yes, yeah, you can. You can use unions, and union file systems complicate everything, but not for us. For us, they're great. In case you don't know what unions are, basically, very simply, you have two file systems mounted on top of each other. One is the bottom file system, the other one's the top. The lookup starts in the bottom, then in the top, and if it's still not found, it will error out. They can nest. The best I got was 30,000, and I think I crashed. So like, good luck securing and coding like this. It's very difficult to do this right. So basically what we do is we mirror Spotlight's directory structure because it has a bit of randomness in it. So we mirror it on the system directory where we can write. We mount over it the actual volume that we have. And if it tactically deletes the target file from top, it's going to fall back to the system volume. And the system volume is the same volume as sudoers is on. So it's just a hard link to sudoers. And that's how you can symlink without symlinks. Well, Apple doesn't like this, so they disallowed union mounts, and they got a bounty, and it took a while. And the conclusion is two things, at least for me, it was two things. One, Apple does pay bounties, so this is a worthwhile endeavor. It can get complicated, but what isn't? And allowing this, my original hunch of allowing disk images to be mounted is quite dangerous. The attacker has all the leverage for all the things I have mentioned. That's how that looks. Takes a bit of time because, first exploit and all that. Okay, that Batman logo seemed like a really good idea at 3 a.m. and probably it wasn't. And it's only one of these. So yeah, I got root. Yeah, yay. So thank you. There's actually 2 demos of this, but I was too lazy to record the second one. It looks identical, so it doesn't really matter. Maybe it's a little bit quicker. So, okay, let's leave Spotlight alone for a little bit. Nah, just joking. So this is actually Bat Signal v3. This didn't occur to me until quite a bit later that, to recap, SQLite writes to insecure volumes, and it won't follow symlinks and union mans. So, I mean, what can I do now? You know, should be airtight. Nah, we can move the man point. We can move it directly, but we can move its parent. So we recpool MDS, and MDS does the same thing. It tries to write to the system volume. Apple's not stupid, though. They prepared for this. So they had all of these restrictions on MDS so that this doesn't happen. Unfortunately, there's 2 lines that allow me to create this lovely directory, which we will call tempdir. I can create this, no problem, as a user, and it's a directory where MDS can actually write to. So rinse and repeat to do the same boring thing. I prepare the directory structure like before, and then I just start to swap the mount points, and eventually I will get lucky. And when I do, MDS will overwrite one of our files that happens to be a hard link to sudoers. Now the bigger problem is, how do I control the content? There's a thing around cache files that I changed that up so I can't use it really. Well, I need a file that I can smuggle payload into and that gets recreated. Obvious target is volume configuration plist because I can smuggle a bogus file exclusion path, I think. And Spotlight is very helpful because it's going to remember this after remount and recreate the file should it go missing. That's how that looks. It gets it in like 68 or something. Yeah, so. Okay, are we good? Yeah, I think we're good. Right, so the last one is bad Maloc. This is a functionality that has existed for, give or take 20 years. I'm coloring it yellow because I want to refer to the Maloc stack logging framework's Maloc stack logging binary, not to the Maloc stack logging functionality, so that it's all clear. It doesn't matter really. So basically, if one of these Maloc stack environment variables are present, the dynamic loader will be nice enough to force load this binary into any binary I choose, including suites, including entitled binaries. This is all well and good. Bless you. Since 2005, frac63 is the first thing I saw on the internet. So it's been around for a while. I don't know if it was always exploitable, or is this new, or old, or something, but it's been around. And basically what this does is it writes a file at an attacker-provided path, and I can load this into any binary I wish. To trigger it, we just set these 2, and yeah, as I said, it just writes out the file. However, Apple obviously thought of this, so there's a bunch of defenses. So the destination, whatever, is checked with access first. Open will be used to create the file. No overwriting and no symlinks. Permissions are restricted, so no UMass trickery, and the file name is randomized. I mean, this worked for 20 years, right? Like, surely no idiot can come and break it. Okay. Access open is a classic talk to. We can race it. We did before. Oh no follow is used and not oh no follow any. The permission restriction is actually going to help us. And the reason it will is because sudo will couple up all these files. However, it will check the permissions. So if the permissions are not right, it's going to refuse to work with it. But Maloc stack logging happens to line it up correctly. And the random generator was hilariously broken. I will have a blog post about that. But it's not really important because the file name, as I said, doesn't matter because sudo is our friend. Problem is, I only have minimal content control because it allocates like addresses and allocation sizes and whatever, and somebody who has actually went to school might be able to figure this out. I couldn't, but I remember that every application can be affected, and the host app has no idea that this happened. And Open does not set ocloexec. So is there an SUID on the system that can leak this file? Well, of course, like slide wouldn't exist. Crontab. Crontab is suid and it executes their editor. It does it properly. This is not Crontab's fault. Crontab will drop all the privileges. However, it does not expect a force-loaded library to have opened a file descriptor. So it's just going to leak it to us. And this is not Crontab's fault again. So this is what we do. We set our editor to our script. We call it, we trigger debug, and we raise the access open by swapping the whatever directory very quickly with a symlink to etc/sudoers.d. And as soon as we win the race, we will know because we have an fd open to a random file under here. So we truncate, write the payload, and be happy. And this is very, very quick. However, I don't find my exploit because I'm clearly a professional, so bear with me. Yeah, there we go. That was it. Like 20 tries, and you got root. In hindsight, I should have recorded this better. Okay, we're all done. Thank you very much. Well, I have a... Thank you. So, I was a bit premature with that, sorry about that. So, thanks to all these lovely people who are sharing their knowledge, and thanks to Apple who have made this possible, and for actually... No, I'm not... That's not actually a joke, but actually to have a program and to actually work on securing these devices is good because they're making my life hell. So thank you very much, and you can find me here and on Twitter and whatever. Thank you very much.
What would you like to say?